For a very simple reason that with the onslaught of lot of jargon of AML, data science and other allied fields, there is a lot of confusion. Okay, that is prevailing across several professors, teachers, and then students, practitioners, everybody. So then I thought, let me dispel, by virtue of working in this particular field for 35.5 years, I thought I am legally qualified to create this unified theory and dispel the confusion or demystify these concepts. Because otherwise, people are thinking that AML and data science are two different islands. And that is not so in fact. And I want to dispel that myth. So that my first part of the talk actually talks about that. And I am sure you will be convinced at the end of the talk. So first of all, let us answer very basic questions. Why should one learn AML at all? Well, it is not rocket science to figure out why one has to learn AML. There is a lot of business at stake. The market support is there, and there is so many fields are converging to AML for getting novel solutions, sophisticated solutions, efficient solutions, and effective solutions. And I will not read out these figures. If these are the kind of businesses that makes, even it makes also a lot of scientific sense. Many of the problems which are unsolved, like protein folding, that is now solvable using alpha protein from DeepMind of Google. So these things were left behind maybe about 10-15 years ago by molecular biologists and bioinformaticians, but then that was easily solved with the advent of deep learning and with the advancements made in the DeepMind. So that makes a lot of scientific sense also to learn AML. And these are some of the slides I want to mention to you, where the market size of AI is growing on year across all domains. It's not specific to healthcare or even agriculture. Across all domains where human being is involved. Okay, and these are all the major industries. And fortunately, healthcare and agriculture is also one of them. There is humongous growth of AML applications in banking and finance, which is the domain that I represent. But I also dabbled in healthcare that I mentioned to you, and I talk about that particular one. Agriculture is something that I have not yet dabbled. Maybe what varies the destiny lies, I don't know. If the problems are interesting enough, maybe I will dabble there also. So there are other kind of service industries where a lot of sense it makes to apply AML technologies for the benefit of the service provider as well as the customer. Fine. Now, having said that, let us come to the fundamental definition of AI. So AI is defined as in fact, Merriam-Webster dictionary defines AI as a branch of computer science dealing with the simulation of intelligent behavior in computers. They mentioned intelligent behavior, they have never said it is human behavior. Madam, I am sharing the slides with you. Please don't take because I am speaking something more important than present here. That's why I require your attention, not just clicking, okay? And it is a capability of a machine to imitate intelligent human behavior. So what is kind of alluded here is, there are a lot of species which are sometimes more powerful and intelligent than humans. And I'm sure some of you know that some of the dog breeds, like golden retriever, it can learn 160 words in any native language that you actually train with. So some of the species are actually bestowed with intelligence by God, and we have to harness that intelligence. Based on this kind of nature and nature-inspired stuff, people have developed lots and lots of algorithms in the optimization domain. And where optimization fits into the entire realm of AML, I am coming to that in a while. Fine. Having said that, Encyclopedia Britannica also states that the AI is the ability of a digital computer or computer-controlled robot to perform tasks normally associated with intelligent beings. They always said intelligent beings, they never said human beings. Please remember that. Okay? And virtually there is no difference between the two definitions. The import of the meaning you should see. And of course, at the core of AI, it constitutes data, algorithms, and computing power. And fortunately for us, in this generation, right now, all the three have converged in a very systematic manner, very proficient manner. Therefore, we are witnessing the growth of AI in a kind of, undefined, in an unforeseen kind of way, method, and that we have not, nobody has kind of predicted this earlier. So, to enable machines to emulate human capabilities and act with higher levels of intelligence, the ability to learn from the patterns in text, speech, image, videos, and any other data, we are referring to unstructured data here. Okay, and here we are referring to the kind of software robots, also called chatbots. And here to provide recommendations has made AI ubiquitous in research and industry, including financial services. Why? So these are the kind of other things that talk about evolution of AI. Pretty much everybody is conversant with this. The last one is very interesting. If you are able to imitate the 5 senses of human being, let me tell you, I will take you 25 years ago, 1997 itself, the artificial nose was created. Artificial nose was created specifically having applications in chemical engineering. Wherever some toxic gases are released in with chemical plants, these chemical sensors will activate upon that, and by interacting with them, we are having chemical reactions, and then some signal will be given, some beep sound will come. That means there is an alarm for all of us as particular working in a particular company or manufacturing industry to come out of that, to go to the separate locations. So that is called artificial nose 25 years ago. Now imagine what kind of accuracy levels you can achieve with the application of the current AI technologies. So and then this is the one. And nowadays we are talking about AICTE and several other things. Okay. On the other hand, machine learning is defined by Herbert Alexander Simon. This guy is a very unique guy, in the sense that if you think that to get a Nobel Prize is very difficult in life, yes, we agree with you. But then this fellow got Turing Award and Nobel Prize. There are very few people, and I think he's only one of them, who have gotten both the awards. Turing Award he got in 1975, Nobel Prize he got in economics in 1978. 2 disparate disciplines. Okay, and this guy defined learning as any process by which a system improves performance from experience. So here he is referring to the human experience, human kind of learning. But then immediately he defined machine learning is concerned with computer programs that automatically improve their performance through experience. So this experience is actually not the human level of experience. It is actually experience referred to by way of presenting the data repeatedly, iteratively, again and again and again. That's what he is referring to. So here itself, he identified the importance of data without actually mentioning it in so many words. Now, we have defined AI, we have defined ML. Now, what is actually happening here, we must see in machine learning, what is the difference between machine learning and the actual human way of learning. So basically, we want to create intelligence on the machine, and then we call it machine intelligence. Once we are creating intelligence in the machine, it is slightly different. In fact, it is vastly different to the human intelligence what God has bestowed upon us. Therefore, it becomes artificial intelligence. Now, who can separate AI, ML, and then machine intelligence? You cannot separate them. Okay? Fine. Then we have attributes of intelligent behavior. I will not read out each one of them, but then you can quickly figure out that many of these traits are found in human beings. If that is so, how do we imitate these kind of traits on the machine with the help of algorithms and solve the problems what we are facing with on a daily basis? Be it agriculture, be it in healthcare, be it in economy, be it in finance. You talk about any kind of discipline, be it physics, chemistry. Okay. So now subsequent slides talk about this kind of Venn diagrams. You can see where machine learning, let me talk about, has got, as we speak today, okay, it has got 9 different flavors. All of us know supervised learning, where a receptacle of x and y matrix is given, x versus y. X is m by n matrix and y is m by 1 vector, where this y is acting like a target variable. Now it is up to you to figure out the functional relationships or the approximate the functional relationship between y vis-a-vis x1, x2, xn. And the better the model does it, the closer the approximation, the better the model is said to be. So you can actually talk about classification task as functional approximation problem. You can talk about regression problem as a functional approximation task. Right? Now, if you have the presence of target variable guiding the entire process of training, then we call it supervised learning. There are a host of algorithms falling under this particular category. As opposed to this, we have got unsupervised learning where the target variable is conspicuously absent, which means by virtue of the natural phenomenon, the y variable is not given to you in the problem definition. Despite that fact, you are asked to figure out some kind of naturally occurring structures and groups in the data. And that is what we are referring to as unsupervised learning. So in order to figure out what is unsupervised learning, you don't have to fall back upon machine learning. Even in statistical realm, people talk about principal component analysis. I'm sure all of you are aware. So principal component analysis was the first, you can say, instance of unsupervised learning. We never talk about y variable there. We make linear transformations of the original X matrix to come out with orthogonal dimensions in a different space purely using linear transformations, which is linear algebra methods. So that is one of the examples. Then we have a lot of other things, that we coming in the unsupervised learning category. Semi-supervised is actually like between the two fields, wherein you have some label, there are samples with the labels and some samples without labels. Then what you have to do is that using the information about the proximity of the samples without labels to the samples having labels, then you have to figure out the approximate labels for the samples that are given without labels. Then that is called semi-supervised learning. Some human intervention is required. But just before the stroke of pandemic, Jan Lekun from New York University, he proposed what is known as self-supervised learning. In which case what happens is, with very little or no intervention, he devised some algorithms which will learn adaptively the labels of the samples without having designated labels priorly. Okay, that is slightly different from semi-supervised. And then the fifth one is representation learning. In representation learning, what happens is you need to figure out some latent variables. These latent variables are not readily available to you, but then the original variables are not good enough, not discriminative enough to solve your classification, regression, forecasting, or clustering problems. In which case, you have to come out with derived variables or latent variables. Latent means hidden in the data. And one of such examples is principal component analysis again. And you got other kind of examples coming from deep learning. We'll talk about that later. So representation learning started with that kind of motto, saying that we need to actually solve the problem very effectively by not only depending upon the original variables given in the data, but by coming out with latent variables either using linear transformations or nonlinear transformations. Fine. Then comes reinforcement learning. So reinforcement learning is, I'm sure many of you are very fond of playing, video games, computer games and all that, even the mobile also. Then many of us are not aware, possibly, that the main ingredient behind all these computer games is reinforcement learning. So reinforcement learning is another kind of trait of human intelligence, whereby human being or agent takes actions based on the feedback given by the environment. And this is how the driverless cars, the driverless vehicles have been kind of structured, and then algorithms are devised. So reinforcement learning has also made inroads into stock market prediction. So basically, wherever human level of intelligence is there, to act with little data, still make decisions, correct decisions, based on the feedback given by the system, that is where reinforcement learning kicks in. So this is another form of machine intelligence, machine learning. And then deep learning, all of us know, basically deep learning is nothing but extraction of derived variables at different levels of layers of neural networks. So at the core of it, deep learning is nothing but set of neural network architectures. So if we say deep learning is a subset of machine learning, answer is yes, resounding yes. But then it doesn't depend on decision trees. It doesn't depend on support vector machines. It is at the core a set of architectures of neural networks, but then having different functionalities. What you were doing manually, all those tasks are now designated with the different layers, hidden layers of the neural network architecture. That means the number of hidden layers increased with a purpose, with a specific task to perform. Then it became deep learning architectures. Vis-a-vis the shallow neural networks, what were in the second generation neural networks. The third generation being the spiking neural networks, which brought us very close to the way human brain works. Fine. And nowadays people talk about deep spiking neural networks also. Okay? And then we have statistical learning. This is very interesting stuff. So somewhere around 1984, in 1984, slightly before that, a group of statisticians from University of California, Berkeley, and then Stanford, these people came together to answer a very interesting question. The question was, it is the statistical community which started proposing and solving these problems in a different way, but the entire credit and it is a popularity is hogged by the computer scientists. So they wanted to correct this scenario by not saying in so many words. Okay? Then they sat together, they figured out what is the lacuna, what is the kind of thing that is missing there. What they figured out is that there is no algorithmic flavor in statistical methods. Then they brought in the algorithmic flavor and then immediately came what is known as the learning capability. So one of the important architectures of statistical learning, which many of us are not aware, is CAR, classification regression trees. That was proposed in 1984 itself. But 2 years later, ID3, I tried to dichotomize an algorithm, was given by Professor Ravi from Australia. He hogged the limelight again. So these people got a sorry figure because by 2 years before that, they gave a general purpose classification regression trees. As the name mentions, it is versatile. It can solve classification problems as well as regression problems by small tweaking in the algorithm, nothing else is at the input level. So this trend continued, and this field is called as statistical computing or computational statistics. Nowadays, it has become so important that without this, if you remove this, entire edifice of deep learning will collapse like a pack of cards. Everything is depending on probabilistic calculations. It started with topic modeling. All of you are aware, I guess. Later they reached the allocation. It started from there, from David Fly, and continuing in the deep learning now. And the transfer learning is very interesting. If you want to learn a new thing, new subject, there are two alternatives. One is learning everything on your own. Otherwise, register for a course and then learn from the expert. If you want to learn everything on your own, given the resources, given the kind of compulsions and considerations and constraints that you face, technical and otherwise, it may take a long time. But if you depend on a person who is already experienced enough, then his or her experience is brought upon to you with the form of lectures, and the brainstorming sessions, hands-on, and all those things. So that is how he or she is actually transferring all the knowledge to the participant or the student in a restricted time. Therefore, okay, then maybe in this particular organization or any organization you want to perform sentiment analysis, let's say you end up with 1 lakh tokens. That is the basic bag of words model. And these 1 lakh tokens or unique words are already a subset of 300 billion words kind of dictionary what Google has prepared. And then trained a network and it is made it ready for use. And these pre-trained networks are just now strategic to image processing also. That means image net is there. For face recognition, face net is there. So many pre-trained neural networks are there. All that is that you have to call the particular library, plug in suitably, and then do the downstream applications, whatever you want to do. So that is actually in fact important thing is that it's taken from the software reuse concept. If we understand the principles of software engineering. Therefore, transfer learning is the 9th, you can say, form of machine learning as we speak today. Don't ask me what will come tomorrow. 10th one may come tomorrow. Okay? So this encapsulates a different perspective of machine learning. Fine. So now these are some of the timelines I quickly browse through. Everything started in 1956 with John McCarthy. I am not interested in going through, these are self-explanatory. This also you would have seen. But I am not very much amused with this. While I agree that deep learning is a subset of machine learning and AI, in fact it should be much more overlapping there than what is depicted here. Anyway, so these are the other new frontiers of AI/ML. People are able to now write horror stories. Anything that is unsupervised or unstructured data that you can generate with the advent of GAN, Generative Adversarial Neural Network. This trend started in 2014. Okay, and then artificial horror stories was written by a tool called Sherry, which basically took the inspiration from GAN, and then you cannot figure out what is written by human being and what is written by an algorithm. The same thing is coming to deep fakes. I'm sure all of you are aware. And then I almost won the literary prize in Japan. Artificial paintings from Pablo Picasso. So many things are there. Real-time machine translation in Skype, different languages. And then deep learning networks diagnose the glaucoma, which is a very serious eye disease, more accurately than the humans. It is happening now. In fact, started happening in 2018 onwards. Predictive maintenance in a large-scale equipment. Okay, as opposed to preventive maintenance, thanks to algorithms from deep learning and big data. And the artificial music composition, development of new particles in physics, chemistry, cognitive cooking from IBM Watson, you name the field, is already there. And most importantly, it has got negative effects on human beings. All of you may not be aware that 1997, Deep Blue has defeated Gary Kasparov, at that time the world champion in chess. They said that he was the greatest of all time and all that. But with all that anecdotes, he was beaten black and blue by Deep Blue. Then he asked for a rematch. He was so competitive, and he beat it. Afterwards, IBM has disbanded that machine for whatever reasons. Exactly 20 years later, similar, in fact, worst thing has happened. In 2017, this guy, Lee et al. When is that? Lee et al. Actually was a Go champion. Go is just like chess, but having much more combinations, permutations and combinations, to the extent of 2 to the power of 170. So those many, that means that more complex than chess. So he was world champion at that time, and AlphaGo defeated him. He was so much frustrated that he went to depression, and nobody knows what happens after him. So that means these are the adverse effects of AI on the society. And Robo 2.0 is not fiction. Let me tell you, it can happen anytime. Thanks to Decker, he is ahead of his time. Okay. And robotic surgeries. Now they are able to do very effective, highly precise surgeries thanks to the advent of deep learning and other things, which were not thinkable earlier. And image processing is one of the disruptive fields, apart from control theory, with the advent of deep learning. I'll talk about that later. It can set tasks. It has models to solve regression problems, classification problems, clustering problems, and outlier detection. At that time, association rule many was not there. Let me tell you. Fine. And this continued. Compressed statistics have this much repertoire. You can say this much variety of techniques coming from various concepts of probability in statistics. Everything is found still a lot of applications and walks of life. And then this trend continued. What about regression? People think that regressions are 1 or 2 types. No, it is not more than half a dozen or even more varieties, depending on the kind of variable that we have, depending on the kind of setting that we have in the problem definition. Fine. Then we have regression is over. Then we have some more slides. Okay, they are coming later. So fine. So these are now we come to shift our attention to the data flood. If we talk about all these disciplines like the service industries like banking, telecom, and then scientific disciplines like astronomy, biology, physics, chemistry, and then talk about web and e-commerce itself. Web 2.0 has fueled the growth of data uploading. That means humongous growth of data across structured, semi-structured, unstructured data happened after the advent of Web 2.0. And then user logs, whenever you perform any e-commerce transaction, user logs will be created. A fantastic example, semi-structured data. Social media data, the less I talk, the better it is. So much of data is there. And then IoT data. So these are all examples of unstructured and semi-structured data. This is where we call this as data growth, as data flood or data tsunami. Okay? Fine. Now, somebody asked me, there is no science behind data science. I could only, I got flabbergasted, and this person happened to be a very senior person. I cannot name him. Then I showed this kind of slide and argued that what nonsense is this. So, first paradigm of science started with performing experiments. In any kind of science, you can say. This trend continued till 1600s. And suddenly they got vexed with conducting experiments. They said, for every small thing we are conducting experiments, we should have think differently. Then started proposing theories. Models started appearing, Newton's laws and all other laws started appearing in that period of 350 years. Then what they said was, if we want to propose some new experiment that can be validated with more general theories. If you want to validate some new theories, we can conduct experiments or refute them to new theories, then also we can conduct experiments. So in both cases, what happened was, there is a symbiotic relationship between experimental paradigm of science and theoretical paradigm of science. This trend continued till 1950, when suddenly something happened, the emergence of computer. That changed the things forever. Then people said, there are some more problems waiting for us, which could not be developed, theories could not be developed for them, and conducting experiments is hazardous, or time-consuming, or prohibitively expensive. In such cases, why don't we just perform the experiment on the machine? that is computer, and if you are successful, we continue, otherwise we leave it there. So with this trend, the computational paradigm of science started in 1950, went up to 2000. Two examples here stand out. One is molecular modeling. Molecular modeling, any computation scientist, chemist sitting here, you will know, molecular modeling is the important precursor for any drug development. If you are seeing a new drug now in the market, it has been ideated 10 years before. Take it from me. Why 10 years before? Because we have to, first and foremost thing is, you have to isolate the candidate drug molecules. Now, we don't even call them drugs. Candidate drug molecules, and then see what kind of bond angle and bond strength it has got while interacting with the specific disease molecules. Depending on that, these drug molecules are isolated and then tested in the laboratory. Then they will go for clinical testing, then pharmacological testing, that is even more lengthy, and finally it goes into chemical engineering, that is bulk drug production. So all these steps take 10 years. Now if this were so, how fortunate we are to have gotten that vaccine for COVID in 1.5 years. Did anybody wonder about this? And nobody talked about it. The science behind that is big data and deep learning. Thanks to those fields, we could get the vaccine as quickly as 1.5 years. Otherwise, it would have taken at least 5 years or even more. So this is you can say societal advantage of having these things. And then we have the fourth paradigm of science, that is around 2000 years. There, what happened was, okay, by virtue of the growth of data and all that, emergence of new field has started in the form of data science or big data science, which is different from all the three predecessors in the sense that we rely on the data only. We don't talk about conducting experiments, or we don't believe in the theories. We don't even go for computational experiments. Rather, we go for computational experiments numerically. Okay? So this is where big data science, or you can say data-driven science, has started this, and fortunately, all the four fields are coexisting peacefully, collaborating, competing, and cooperating with each other. That is the important thing we need to notice. So now can anybody argue that there is no science behind data science? No. You will see that. So having said that, these are the two definitions of data science. One is coming from IBM, a very powerful IT company, and the other coming from a service company. Okay? So data science combines math, statistics, specialized programming, advanced analytics, AI and ML. Already they included AI and ML as part of data science. But it's unfortunate that many people do not realize this. And I speak this with a lot of anguish. They think that these are two different islands, and they are trying to draw boundaries in the water. Just like two political nations draw this and start fighting over, and wars also happen. It's not like that. Similarly, look at the second definition. They are the same. So how can we separate data science and AML? It is ridiculous. And I'll tell you one more. So these are if you want to figure out why data science is important, these are all the statistics. I will not read through again. There is a lot of market size, market size in terms of US dollars in millions. Data science platforms are very important for this. And then we have what kind of fields that are getting impacted. Virtual endless. And these are the other year-on-year compounded average growth rate. And on-prem or even cloud implementations, these are kind of breakup. Now these with respect to the tools. For example, RapidMiner. Some of you are aware. RapidMiner was launched as a data mining tool. Now it has become a full-fledged data science tool. So what is the distinction between data mining and data science? Wait for a while. I'll answer that question. And other things are there. Wolfram, that is Wolfram is from Mathematica. This company has forayed into data science also. Fine. And these are other domains we started using. And it's not sufficient. New titles have started coming in. Python developer, Android, data engineer, CRM developer, customer relationship management, CRM developer. These were not there earlier, unthinkable. Fine. And these are countries which are the forefront of the application of data science, and we are not lagging behind, let me tell you. We are right up there with all the advanced nations. Thanks to the advancements, and you can say forward thinking of central government, I must say. Now this slide, we are talking about 2002. We are in 2023, knocking the doors of 2024. Is this slide a typo or is it by mistake it has come here? Can somebody respond? Is it by mistake this slide has come or is it a typo? It should have been 2022? It is 2002 only, there is no typo. It is for a specific purpose I kept this slide just to let you know that this data growth what we have been talking about started in 2002, where UC Berkeley estimated that 5 exabytes of new data was created in 2002. That is a big thing now, at that time. But now you want to know how much data we are creating? 2.5 exabytes daily. Forget 1 year. 2.5 exabytes of data daily. And what data we are referring to? Structured, semi-structured, unstructured. And it only already what it constitutes. I don't have to go back to the slides. Now, important thing here is, US is the chief producer and very little data will not be looked at by human beings. That is a very important thing. Now, therefore, a new discipline has started at that time called as data mining. Now, what is the data challenge here? Data challenge is, as the time progresses, the data content is growing at exponential pace and data utilization is hardly going at a linear pace. Now, importantly, we need to bridge this yawning gap. There are two solutions for this. First solution is, you should have more and more sophisticated algorithms, more and more powerful algorithms to take the data as soon as it arrived. That is number one. And fortunately, on a monthly basis, if not weekly basis, we are getting newer and newer algorithms to tackle this aspect. But the crunch issue is actually having pointers to this FDP. Crunch issue is there is a severe human resource crunch. This trend was observed in early 2006. McKinsey, all of you know, McKinsey estimated that in 2000 there is a depth of 200,000, that is 2 lakh data miners in the US alone. And by 2020, they said this number will become 1 million. This is indeed the case. There were so many jobs up for grabs right now. It is because of this reason, 15-20 years ago, all the top universities started giving specialized degrees, not for a BTech, master's program in predictive analytics, master's in business analytics, master's in data science. These things started at that. Slowly, India also got into the trend. And first IIT was IIT Hyderabad. IIT Hyderabad. We started BTech program. But MTech, in AI was started by University of Hyderabad long ago, when AI was not in the prominence as we are seeing this. That's the difference again altogether. After that, I saw one engineering college, GH Raisoni College in Nagpur. They did this. And later on, everybody started. Okay, that's a different point. Now, so because of this, severe human resource crunch is there. Therefore, we have to have qualified and trained manpower. Please remember this. Anybody and everybody cannot do this. I'm sure who are into this field, you realize and vouch for me what I say. Anybody cannot just be transplanted into this area and then do wonders from tomorrow onwards. You cannot do. You have to have proper qualification in this. Be it bachelor's, master's, PhD, whatever, or all of them together. Depending on what you are doing, you will be placed at different levels. That's a different point. But you should be qualified. Second thing is, training also is happening. It should be happening because the entire technology is growing at a breakneck speed. That is another thing that we have to realize. Therefore, this slide is very important. Now, having defined that, what is data mining? Data mining is the non-trivial process of extracting useful, non-obvious and actionable knowledge from huge amounts of data. Please remember, we are getting knowledge, not information, as opposed to business intelligence or OLAP. And then what kind of knowledge is this? It should be useful, non-obvious and actionable. You can take decisions, scientific decisions or business decisions based on that knowledge. And having said that, it was not a new discipline. It was a consortium of statistics, operations research, databases and machine learning put together that became an umbrella discipline. I start using the word umbrella now. Umbrella discipline at that stage, somewhere in the middle of it started in 1989, slowly gained popularity and then became, data mining. 7 words were coined, data mining became the most acceptable word, and then this became like this. It's not 4 different disparate disciplines. Before the advent of this discipline called data mining, these disciplines were not talking eye to each other. No handshake at all. Thanks to this field, all the professionals from the 4 fields started kind of at least having a dialogue, handshake, and perfect collaborations. Competitions Why competition? If you give that algorithm, I will improve your algorithm from my family of thing. These are 4 different families, that kind of thing. So here the problem solving became more important than which field you came from. Please remember, that has become the motto of data mining at that time. Now, primarily, please remember, data mining was restricted to solving structured data only. This is something important that all of you have to remember. Now, slowly we go further. Then another word was called analytics, somewhere around 2000s. Then they said, analytics is another umbrella, slightly bigger umbrella than data mining, but then it has got 3 different flavors. Descriptive analytics, describing pictorially. Please remember, pictorially. That means having pictures. We already talked about descriptive statistics. What is known already? So, descriptive statistics, OLAP. OLAP stands for Online Analytical Processing. It's a very important field. Vendors call it as, business intelligence. That's a different point. And the second one is more involved than this, predictive analytics, which means predicting what is going to happen. So here you fields like data mining, text mining, web mining, all these things come here. So your umbrella discipline of data mining became a subset of analytics in the form of predictive analytics. How nice it is. But here, in all the 3 cases, there is an element of probability of something happening. It could be probability of these kind of people getting some certain disease. It is probability of getting those kind of crops getting another disease. So on and so forth. And finally, the third flavor is prescriptive. It provides insights and recommendations. That is where you apply optimization techniques, both linear and non-linear. Once you say non-linear, your entire branch of evolution computation comes in. Genetic algorithms, differential evolution, particle form optimization, all of them are basically tools to solve optimization problems. Now you tell me in every walk of life there is an optimization problem. Whether you are illiterate or illiterate, everybody does optimization. Right from the day, the time that you get up to the time that you actually go to the bed. Everybody does optimization. So, many of them are actually linear programming problems or non-linear programming problems. Fine? So, these are already structured. Now, the umbrella has gotten bigger, become bigger. But then, already 3 things are created already, structured, semi-structured, unstructured data are getting covered already here. Fine. Then we go further. These are the 5 tasks all of us know. Available data mining, I will not go through them for the paucity of time. Association rule mining, classification, clustering, forecasting or regression, both are more or less the same. And then outlet detection. Now, entire data mining encapsulates about these 5 only, and the surrounding algorithms that are available for them. And from which a lot of books are written. My request to the faculty members sitting here is, if you teach subject like data mining like this to students, it will become life will become easy for you as well as for the student. Deep RL. Did I cost function loss fermentation we have drug molecules after the 20 years. Now that I also have to come out with the prediction, another is to meet the prediction, and that is where causal inference is coming. Cross-functional scientific problem, then you should not work on a domain expert and go for data preparation, or you check with the domain autonomously. Like the final stage. So data would have become. It's a continuous and you can like 26 years old. Like 26 years old now. One is adversary. If we attach the duration of the attack, assuming that there will be very high happening scientific problem, we have to use that particular max count the number of trees in high coefficient. Let us say the length of the trees out of 20,000 on the occurring river, it's got lot of inflation. How do you do? But now we want double. Fantastic. And the last day, not even 30 members, that I give you the parameters of neural network. GPT-3, so I'm coming back. So there are a number of trainable. You are owning that car. And suddenly a dealer only take it 3 weeks ago. So because we are not going to work on, it's the very reason anybody can do anything, will be affected. It's very important. Organizations, the organizations came together, is neither that country organization. Model is encrypted, not of practical ramification data and model. One, if you use, navigation, pattern learning, if you are using Europe, when I do 1 kilometer, nobody was there, particular person. No, there something is happening. These have got various domains of one, US, so not Sydney, that's a different. To accurately predict, in ophthalmology they do and all that. It takes several images. Diabetes people who have a young student, tech student from University of Hyderabad, where the work is small enough according to US, on the other hand, they domains where they are fuzzy clustering from the malign tumors. Manufacturing length enough. That only thing is that basis. That is very important. Other people, right? Other Hyderabad, they don't do this. Shared, you can. So this is the one. Journals told you need to take pains. So that means there is also there ethical concerns. Yeah. And of course, hardware, what can science in a big way. So these are other things. That means I'm talking about some crops, you technologically this AgriStat is for giving credit to farmers. Foremost thing is you should ask a question to yourself by one for ingestion. These three chain. So these are the of scalability and dumping information here. I want to caution you. We started with sport. So what I'm trying to tell you is that, and then put in the report. Nobody, in fact, validate this before release. American statistical software results what you actually. The author who is saying this itself. They say, this is what I insist on my crash. So that is corrected, Initial is fraud, not ecology, this right is fraud. Yeah, again, market figures. Food and Agricultural Organization, UNO. Analysis, data science algorithms. Israel is one tiny country which has actually put it by several other countries. This is diagnosis. Just by having image, not so. Entrepreneur gets affected. I told you a lot of methods. On a predictive model. On top of that, take the image. I told you coming from to figure out. So it's called. What do you want to give him? Okay. I think this is very interesting. And these one interact with the forest strawberry harvesting and agriculture law. All of you much advanced. Why still we can adopt this? You should not get So this way back in 1990 advanced, but here and then we are AI and all of these. If I use the temperatures are high during monsoon. The wings concentration that will have not just estimated economic value. This high estimated. No, I am not happy. Price of making one is communication productivity is getting within the for agriculture within generative. If you lose the job, yes and no. It depends on. If you think that you are not fortunate, advancement, cycle gang, etc., you can learning is cutting both ways. Unfortunately, suddenly you want to. If data imbalance creating that, but thing is also important. Okay, these are actually augmenting it. Nation rich agriculture for you. And nowadays actually trying to do this. Papers are there. Applied to look at this. And then A then other publish and any questions please. One more. This one rare plant disease. So that is a kind of tradition that means is genuine and there we have got smoting. Some other examples. Right, so and great technologies to succeed. All of us no quality, bad quality.
We request